Alright, so it was pretty hot and nasty today, so I had to revisit this thing because I tripped the BMS and I had to pull all this other crap. So I just kind of thought, well, I'm having a balancing problem with this one here, and I'm like, well, so we're having a balancing problem with two batteries in the 24 volt. So let's just go and add the other two batteries. So there's two. You can't see them either, no matter what way I put them. I got to get longer jumpers, and I can flip it around to where I can see it because they won't reach. They put the pretty side of the battery on the inside. So we got over in here, we get a Chins 100 amp hour, and I put them kind of in staggered formation, kind of keep them maybe a little more balanced. These are Weeze batteries. They're all the same, basically. They look like they're made by the same place. There's a possibility that these might not be pouch cells and these might be. I'm not opening the damn thing to find out. So pouch cells are going to act a little bit differently than regular prismatic cells. So we've got these over here. I need to get another cap on that one. I just feel better if I have one on there. And then the grid is coming in here temporarily. What we wanted to do was see how is this going to behave, because what happens is I can't, when I had two Chins batteries and an old Lifetime Amper Time battery, it's not old, it's just that like the guy I bought it from had it sit for at least 2 years or a year. About 2 years ago, Amper Time changed their name to Lifetime. Anyway, so this is the oldest battery that I own that's lithium. My very first one I ever owned. And I was like dumbfounded. I mean, I've been using stuff like this. I was absolutely just wow, you know. So anyway, it didn't balance well with these or something, because the BMS would trip on that battery and not the other two. See, that's the problem when you have multiple batteries with their own individual BMSs. Any one of the batteries could be out of balance and it will go down lower than the rest of the batteries, and then the BMS trips and cuts off the battery to protect it from low voltage cutoff. Now you have an open circuit because that BMS and that battery just shut down, and then you either got to wake the battery up or you wait for it to come back. And so that's what happened earlier today, and I said screw this. So I started to plug my inverter in to see if it would wake up the BMS, and it never did. So I decided to pull the two Weeze batteries and swap them for that one. And we'll put this one, I want to move this somewhere else. I really don't want all this crap out here. But then again, I don't trust Chinese inverters, and if something would happen, I'd rather have it out in the shop and not in the house. So anyway, we'll see if these balance a little bit better. I need to get a few more of these voltmeters, and usually I would keep one of these on each battery. You need to calibrate them too. They have a little calibration. They're off by quite a bit on some of them, but they can be calibrated. They're really kind of neat. We might actually use one of these in a power supply build that we're going to be doing out of one of these old power supplies. Let's see if we can just like cut a hole in it and put it in there. But anyway, I need more of those. I'll put one on each battery, just that way you can look down and see how balanced they are. But what I'm doing right now is I'm playing with the on and off voltage levels. As what point does the grid come on or off? It's really complicated with this Eg4. And then they not only did that, but they changed the way that the whole thing looks, and they've kind of made it a little bit simpler. We have this deal here. You need to always click this button that says read, and then you'll see the time in there, and then it'll read your settings. But what I prefer is the old page is what it says. They have two options: use setting page by default, or use the other one. And then there's this other working mode tab. If you click on that, that's this one, working mode, and then old page setting. Okay. You use setting page by default, which is this one. And I don't know why they did updates and changed everything. So we're using lithium batteries, but they don't have smart BMSs. So the way that these inverters work is they normally would communicate with the BMS over Bluetooth, and it has to be a protocol that it works with. There are other ones that actually have cables that you hook an Ethernet cable to your battery bank. So you see like those big, huge, 48 volt, 100 amp hour, 200 amp hour, big, huge, metal things in a server rack. So we got to put it on lead acid at 100 amp hour, and because every one of these batteries is in series with each other, and they're 100 amp hours. So I've got I put it on. It should be on utility. I don't want it on utility. I want it on utility range, 170 to 280 volts. What that just means is this 10 milliseconds delay for it to switch over, and then you click set, and if it's successful to do that, and then you got PV arc fault. RSD is rapid shutdown. I'm not sure if that's something I want to use. You can neutral bond, enable it or don't enable it. We don't want it enabled because we're plugged into the grid, so the grid is supplementing. It's not actually really supplementing because this isn't a hybrid inverter. What it does is when it reaches a certain voltage, the grid kicks on, takes over the load, and also charges the battery, or however you set it. So we have our settings that we want. The charge voltage. I was looking at some charts. I think 58 point something is considered a full charge at resting, and then 54, or excuse me, not at resting, while charging, and then at resting it's like 54. But so with charge voltage we want like 56.4. I think that's probably a good number. And then the float at 54, and there's no equalization. I don't have that on, but if you had lead acid batteries you would want to do that. These are the default numbers. I think these are all default numbers that they put in here, but they're good enough for me. And then AC charge is based on whatever you want to select. Disable time, battery voltage. So you could have this thing to like basically act like as a UPS, and you could say, oh well, my off-peak hours are, let's say, 7 or 8 p.m. to 3 p.m. in the afternoon. So peak hours here, like I think, are usually 3 to 7 or 3 to 8 or 2 to 8. And so you could have this thing set to continually be charged and ready to use at those times. So then you just discharge the battery between 2 and 8 p.m. and then recharge it back up when, like for instance here at that time, it's 12 cents a kilowatt hour versus 34 on peak. I mean, it's bad. 34 on peak is bad. And they got everybody coming home using their air conditioners, their cook stove, their this or that, so 34 cents is almost triple, basically almost triple the 12 cents. So you could use this to save money just by doing that. I mean, because you could run, like we just run it. I run the air conditioner out here off of it, and I run another one in the bedroom, and they're not tied to the house grid at all. They're independent. They're basically off-grid air conditioners. And there's a third one in the kitchen area, and that one runs off of a completely different setup, which I want to move somewhere else. I wish I just had a waterproof one of these, so that I just mount these on the back porch and get them the hell out of here. I wouldn't have to listen to the fans on them. But anyway, So you could set your battery charge based on voltage, state of charge, voltage and time, state of charge and time. So you can only do state of charge if you're using a smart BMS. So in our case here, we could just do battery voltage, but you could set it to just come on at a certain time if you don't have solar. I mean, but think about it. You could have one of these, and if you had, like, if you want to spend the money and get an automatic transfer switch, you could have it wired up to your house for that purpose. And, you know, the power goes out, it would automatically kick on and power your critical loads. You can almost power a whole house on one of these, almost, but not quite. So we just want to not have to pay for these air conditioners running all the time, and because the house doesn't have central air, it's just easier to power up externally a few air conditioners. And so so I just want it to kick on when the battery voltage gets to a certain point, so that, I guess, basically what we can then do is just keep the system completely charged all the time, so the battery never goes on into cutoff, and then that way whatever critical loads are on this inverter will always be on 24/7. Now, traditionally, I would just run it until it hit the low voltage cutoff set on the inverter, and I'd have it cut off really high at like 51 volts, which is like probably, it's not, 48 is like 10%. So if you get like 50 is about 15%. I think 51% is like maybe 30% battery left. I don't like to discharge the thing completely, but so I'd have it set to cut off, and then what would happen is it would cut off, and then the inverter would shut itself down. And in the morning, the sun would start coming in, and it would start charging the battery, and then boom, it would turn on. And if you have the right setup, the air conditioner will just automatically turn itself back on. We have the big air conditioner in the kitchen area does not turn back on after power goes out. These ones out here, they do. They automatically turn right back on. They might default to eco mode, but they definitely turn back on. And so that's kind of nice. So anyway, you can set the voltage that you want it to start charging at. Like I put it at 50 volts because that's like when it's already down to like 15%. And then I have it set to just stop at 53. And I figure that's like 80% or 60%, somewhere around there. It's just enough. I just want to keep the battery up, and I don't want to rely upon the grid. I want the solar to do its job. And then you have the whole generator setting. I'm not going to mess with that because I don't have a generator. And then your discharge settings. These ones are kind of get a little bit confusing for me, but the discharge cutoff voltage, and you have a warning voltage, and it's got to be higher than the cutoff voltage. And also, you need to make sure too, if you can't get this thing to charge, your charging voltage is got to be lower than your end battery charging voltage. So make sure you catch that if you have one of these. So this one here, the on-grid EOD voltage, I'm not really sure I understand what that one is supposed to do, but the discharge cutoff voltage is 50. So it's supposed to stop the battery from discharging at 50 volts. That means it's supposed to switch over. And it's also at the same time supposed to start charging the battery. So you can have this like stupid where it won't start charging the battery. I don't know why you would want it to wait even more. Like, well, you want it to charge the battery as soon as it hits the cutoff. But then I don't know what the on-grid voltage is. So with that EOD in there, I don't know what that means. I thought it was something discharged. Now, I think it might be, and you can hover over the question marks on any of these. It says, when battery reaches, and this is like Chinglish, when battery reach the value you set, it will stop discharging and AC kicks in. Ranges between 40 and 58 volts. Okay, so when the battery reaches the value you set, it will stop discharging and AC kicks in. So the battery will stop discharging at 50 volts and the AC will kick in and take over the load and charge the battery at the same time. And then you have this other thing. I don't know what smart load does. I don't have it enabled, but I think it's got to do with the generator. And then you can change the fan settings if you don't like the fans. They look like they're set at 70%. I thought they were all the way, but anyway, we'll come back over here. I noticed you can go into this one, and your numbers aren't going to be the same. Like, let me just double check this thing. So you have parallel settings. You have the working mode setting. And I don't know. Let's see. If you click that, then it goes to AC charge. Okay. And you can set these things here and the time and all that. It just gets confusing. So there's AC first mode, which I don't know, I guess that's the time that it comes on. And then you have the self-consumption mode, charge current limiting ADC, 125 volts, 125 amps DC. That's pretty high. And then you have discharging over here. I set it to 100 amps. I don't want it to discharge more than what they're rated at. I mean they'll give more than, let me put it this way. 100 amp hours is not necessarily 100 amps output. These batteries can provide way more than 100 amps if you suddenly put a major load on them. There's a cutoff usually on the BMS at 150 on most 100 amp hour batteries. Most of them. So I want that under that. I don't want to be causing myself problems. I don't really want to dump 125 amps into the battery either. I have a feeling that's probably not going to happen too often. Maybe the peak of the day. So this is kind of like a quick setting. So we're on battery settings, AC first, AC charge, and then active mode you can't click on, and then self-consumption. So, okay. The max charge current limitation of the entire system. So if you screw with this, it might also screw with how much power the inverter can put out too. So, anyway, you see right now, we're charging. I have the air conditioning on. We've now kicked back over, and we probably hit the 50 volt cutoff. We're supplying 1044 watts to the two air conditioners. So, and the battery is sucking up 1533. So we're basically pulling 2718 from the grid. And that's why I want to change that, because I don't want that much power going into the battery. So that's why I was making this video, to kind of show you guys this. So I'm fiddling with this thing because I think it's confusing, and maybe I might be able to confuse you even more. No, I'm just trying to document it for my own purposes and maybe help somebody else. We got to come up here and click the read thing though. Let's just see what they have for the rate. Parallel settings, AC first. Lead acid capacity. Okay. Current limiting. Charge current limit. No, I thought there was one here that was set to 30 volts. AC charge battery current. It says 30 amps. But up here, it says 125. But that is supposed to be for the entire system. But 30 amps is not 1,000 watts, I don't think. What would 30 be times 48? I guess it would be. So let's try going here with this. Let's go 15. We'll set 15. And our number should drop in half. Okay. You can hear the fan ramp down. Now, this monitor goes to a website. So you don't see it immediately. Okay? It takes a while. And, I mean, it's like sometimes up to a minute before the changes you make are reflected. So you got to sit here and wait. What's cool is I know exactly what's going on. When I look at this, I say, oh, it's drawing 662. It means one of the other air conditioners has cycled itself off. But, so we've done 2,094 kilowatt hours, which is almost 2.1 megawatts since August of last year. My typical amount that I put out, and it's a new month, but let's see what they show here. We made 14.8 kilowatt hours yesterday. So what that really means is that maybe we made 1,000 watts for 14 hours. So what it really breaks down to, you don't have 14 hours of sunlight. So there's particularly, let's say you made 2,000 watts and you made it for 2 hours. Well, you just have to do the math. But that doesn't mean like the system was making 14 kilowatts instantaneous. Like it's adding it up. It's kind of weird how it can get really confusing when you're new, because you're like, well, what the hell? That's a lot of power. Well, no, because it was probably between 1 and 2,000 watts at any given time, which really isn't that much, considering, you know, the average house probably needs between 5 and 10 kW, you know, for loads. So now this inverter will go up to 6,000 watts, and it will peak for like 30 seconds at 1,200 watts. And there's been lots of people that have tested it. It'll actually go over that. It's basically a Lux Power, which is more of a commercial brand. And that's why I wanted to get away from like MPP Solar and these other companies. They're just not that good compared to something like the Eg4. Now, the older Eg4s are definitely the same as the MPP Solars and stuff like that. They're made by SRNE or whatever. But this one's different. So, and this went up about $300 or $400 since I bought it last year. I went on Santan Solar's website, and it's not $1,400 no more. It's like $1,700. It's nuts. So Eg4, let's go over here and take a look. Oh, come on. They got the Eg4 1200 XP off-grid inverter, split phase, 2499. That's the one I would love to have. If I ever get big on YouTube, I'm gonna buy one of those. Well, actually, I would probably buy a waterproof one, because I don't want it in here. I want it outside. Here's the $15,000. I mean, like, they're just nuts. And they'll charge you whatever. This one here, they say it's you know, they just sell you like this kit, you know. This is a really cool deal here. These things, they used to be really cheap too. It's a 12K BTU hybrid AC/DC mini split air conditioner heat pump, and it literally, you could just hook it up batteryless. It can run off of just direct solar panels, no charge controller, no inverter, no nothing. Or you can hook it to the grid, or whatever, however you want to do it. They're really cool. But this is an Eg4 one. They used to carry a different one. So this one here is called the 12K PV. That's kind of, some of these are sort of deceptive. 12,000 watt input, 8,000 watt output. So it's not a 12,000 watt inverter. It's an 8,000 watt inverter that can handle excessive amounts of solar input. Trust me, if you got 12,000 watts of solar, you're running a farm. I mean, like, I got 30 panels, used panels from Santan, and well, I don't get more than, I might be able to push it hard and get like 3,000 watts. You know, the 30 panels are all in the same direction, and everything is great, and they're all, you know, perfect. Then you can do really well. But I've just found that the used panels, on average, are really, you get a 240 watt used panel, you're probably going to see 100 to 200 watts, you know. And the way I got everything set up, it's not possible really to put everything how I want it. Here's an 18. They've got so many of these things now. So here's the Eg4. This is the one I have. And you can buy them bundled with a battery too. I don't know. But these were $1,400. They were $1,449 last year. And right after I bought the damn thing, 30 days after I bought it, they went on sale. They were like $1,300. And I called them up and I was like, dude, you just put this thing on sale. Actually, it's not even been 30 days. And they never called me back. Bunch of dicks. It's like, seriously, I just bought this thing and you put it on sale like 15 days later. They're like, yeah, well, we're going to talk to the manager. We'll let you know if we can, yeah, if we definitely for sure, yeah. And so I never heard nothing back. I don't really care for the people over here as far as like the ass kissers. And I just, like, there's so many different people working there. And like, they told me before, you can return anything if you don't like it. And then I'm like, all right, are you sure? Yep. And so I returned a couple of inverters, cheap ones, you know, like the reliable inverters. I don't think they sell them anymore. And I bought this green thing here, a different one from them, and I didn't like it. And I said, look, I want to bring back this inverter, these charge controllers, and I'm going to buy the MPP Solar HVLV 6500 or whatever it was, the 6.5 kW 48 volt system, and it just turned into a fiasco. But they were like, so they started to process the deal. They processed all the returns, and then, you know, I had to add some cash to it, and they actually screwed up and counted my money wrong. They didn't give me the proper change back, and then they said, look, if you open this box, you own it, you can't bring it back unless it's absolutely broken. And I'm like, but your policy says, and you've told me if I don't like it or it doesn't work how I want it to work, I can return it for any reason, no questions asked. And they said, well, you've returned too many things, or, you know, that's what they were trying to say. And I said, I don't want it then. I said, I don't want it. I said, so go ahead and just give me my money back. And of course, they couldn't give me my damn money back because part of it was on a card. And they're like, well, we can't do this, and we can't do that. And we can give you partial cash back. And that's when I found out how they shortchanged me. And I actually got my money back. I would have lost, like, I don't remember. It was a couple $100 that they screwed me by. I took back a couple of pieces of the equipment. I did not take back the green thing. I took back two. No, I just took back maybe one. One charge controller and the stupid $350 inverter. And so I never wanted to deal with them again. But unfortunately, they're the only like local place that has this, and they don't charge tax on this stuff. So it'd be, you know, it's easier for me to deal with them than Signature Solar. I can drive down there. Anyway, I don't recommend dealing with them if you think you might have to return something. you know, because they just, you know, they're full of crap, you know. And I've helped them a whole bunch too. I was like, hey, I'm making videos about your stuff. And, you know, I mean, if you look on my channel, I've got an Eg4 video. It's got 37,000 views. They sell Eg4 charge controllers. And I reviewed it and I linked it for them. I probably made them a ton of money. And I had an affiliate account with them. Never did they ever send me a fucking dime. Nothing. And when it comes to that kind of stuff, like Eg4 charge controllers, please buy them on Amazon. Don't buy them from these guys. Because at least with Amazon, you got 30 days to return it and you get your money back. And these guys, they'll give you a year warranty on it, but I don't know what would happen if something happens. They claim that. But from my experience of dealing with them, I don't think I would want to have to put it to the test. So hopefully nothing happens with this unit, because they'd basically be like throwing $1,400 down the toilet. That's why I always get real nervous ordering expensive Chinese stuff like this. I don't mind buying lots of little pieces at a time, like, you know, individual, like how I have here. I've got individual charge controllers, individual inverters. You know, that's a 2.4 and that's a 3. You know, between the two of them, it's almost as much as this damn thing, but they make noise and they're lousy. You know, so anyway, it's just my 2 cents. If you want to buy one of these and you don't think you're going to have a problem with it, buy it from them. Or, you know, Signature Solar. Signature Solar, they've had some problems in the past. And you can read about it on the DIY Solar forum. But they do try and reach out. And so, I don't know. It's just, I don't know. But what's cool about this inverter, you got all your circuit breakers in it. There's a battery breaker, there's a load breaker, there's a grid breaker, and there's a generator breaker. And you just don't get that with the other ones unless you're buying the commercial stuff. So this is kind of in between like tier 1 commercial stuff. The fans on it are definitely loud. You can hear them running right now. They're noisy. And after a while it gets annoying because it's sitting here right in front of my face. But if you don't have it behind your TV next to your radios, you're not going to have that problem. To me, I don't have any problem with RFI from this one, but I tell you, I could turn up this green one and I can just watch the spikes pop up out of the damn blue. I mean, like right now, we're on here. I mean, you know. So, anyway, I've done a lot of videos on solar in the past, but I generally don't make that many videos about it anymore. I don't know. My subscriber base is kind of strange, I think. In the beginning, most of the views on my channel were not from subscribers. And so I watch this phenomenon every day where I have 3 or 4 people unsubscribe and 3 or 4 people subscribe. 5 or 6 subscribe. 2 or 3 unsubscribe. And I never used to see that on YouTube. So I've been kind of trying to stick a little bit more to the meat and bones of things, to the ham radio. And, you know, I know a lot of hams are into the same stuff and they're curious about the same stuff. But I think also I'm trying to make money on YouTube to help pay my bills. And I figured out a formula that guarantees me to make $200 a month. I know that doesn't sound like much, but if I don't put out close to 10 videos a day, I don't make crap. But if I do 10 videos a day or close to that, and just document what I do through my daily life, I can make about $200 a month. I mean, think about it. That's more money than what I'm getting from the solar. The solar covers about 30 or 40 bucks a month. You know? So, I'm getting paid to make videos and talk about stuff that I like. So, but what happens is when you put out 10 videos a day, well, there's only 3 notifications that go out anyways, but I guess some people get annoyed by it. We'll just turn off notifications. You don't need to have them on. So I've been trying not to make as many of these other videos like this, just for that reason. But anyway, I wanted to discuss this because I'm kind of playing around with it, and maybe you guys are curious about it. We have a notice here. It gives you a little notice in the overview. Oh, we're in the old monitor. Let's close this out. Okay. So once we hit 53 volts here, this will stop charging. So it's putting in 751 watts into the battery instead of like whatever it was before. So we can go in here and drag it out a little bit more. Let's click read. We'll come down here and where's our battery charge voltage? 15. Let's do 8 amps. Or how about, yeah, we'll do 8. Let's just see 8 because 8's almost half of 15. I want to see. Another thing too is if you charge it slower, you get less noise. As it charges more or has a heavier load, the fans really start to ramp up. And it's probably at least a minute, 30 seconds or somewhere around there before you can update the screen and see the new information. If you really wanted to know, you'd have to come over here and go look at the inverter, which for me is kind of a pain. And I can see what's kind of going on, but you don't get the same screen. So with this particular inverter, it's really a pain in the butt. Where you see the battery is at 52.5 volts. Where you see 390, and you gotta figure out what that is. 0.3938 kilowatts, 380 watts. So then we come into here, we should be able to update it, and it should read something similar to that. It's still not updating. Like I said, it can be really slow and it's annoying. And you definitely want the beep on, because if you touch this, it's like you don't even have to touch it. So that's all the information it's giving me. Still not updated. That's like, you gotta be kidding me. How many minutes? Not updated. Alright, finally updated. That was probably well over 2 minutes. So I'm just gonna keep the draw low. Yeah, I don't want to be sucking up a ton of power, because as soon as like 8 o'clock or 9 o'clock comes, it will be full bore on the solar. I think it starts to make power around 6 or 7. Well, anyway, guys, I decided to share this video with you guys about the Eg4 and my solar setup and all that. I'm sure it's probably not all that amusing to most people, but I kind of document what I do on the channel, so we'll catch you guys in another video.